Hello everyone, welcome to the channel Understanding Concepts of Physics. We are here with another numerical, and you can pause the video and just go through the question. It's a very small numerical. It's going to be a very small derivation, solving of numerical. Potential energy is given, and that potential energy is given in joules, and this is the particle's potential energy in linear simple harmonic motion. And the mass is given as 20 grams. So there are two data given, and the third data, that is the frequency of SHM, is something we are supposed to find out. And then answer should come somewhere around here. Let's see if we are able to get it. So potential energy is basically given as 0.1 pi square x square in joules. So joule is basically an SI unit, so not a worry. Mass is given as in 20 grams, so that has to be converted into kg. So 20 grams to kg is 10 raised to minus 3 kgs. So 1 gram is 10 raised to minus 3 kg. So 20 grams would be 20 into 10 raised to minus 3 kgs. And we are supposed to find out the frequency of that oscillating body. So let's see. So in this, we should be knowing that what is the potential energy formula for a particle in SHM, and that is half of m omega square x square. This is the formula for potential energy in an SHM. Then I have put the value of potential energy which was in the given data, that is 0.1 pi square x square. This was given in the question, and in place of omega I am just writing as 2 pi f. So omega has two formulas. This is a very well used formula, 2 pi by t and 2 pi f. This is the most used formula in the entire course of grade 11 and 12. So mass into 2 pi f the whole square into x square. This is it as it is. Then I am seeing that x square and x square gets cancelled, so that's why you are not seeing that x square here. I am just squaring this term. So 2 ka square is 4, and pi square is pi square, and f square is f square. So I am seeing that pi square also can get cancelled. That's why you will see there are no pi's in this equation. Then I want f, so I'll make the f as my subject. So keep f on one side and take this everything on the other side. So everything on the other side means this 2 will go in the numerator. This 20 into 10 raised to minus 3 into 4 will come in the denominator. So 2 goes in the numerator and this. So it will look like this: 0.1 times 2 upon 20 into 10 raised to minus 3 into 4. And from here, 2 1s are 2 10s are. So I get 0.1 upon 10 into 10 raised to minus 3. Now if you see, this is 10 raised to 1. If there is nothing, that is 10 raised to 1. So minus 3 plus 1 will give me minus 2. So there is a 10 raised to minus 2 in the denominator, 10 raised to minus 2 in the denominator, and you have a 10 raised to minus 1 in the numerator. 0.1 is basically 10 raised to minus 1. So when this 10 raised to minus 2 goes up, it will become 10 raised to minus 1 into 10 raised to plus 2. The minus 2 will become plus 2. This is plus 2. So plus 2 minus 1 will give me 10 raised to plus 1. And this 10 raised to plus 1 is what I have written over here. When we do not write anything, that means it implies that it's 1. So solving this entire thing will give me 10 upon 4. I need a square. I don't need a square of frequency, I need a frequency. So frequency would be equal to root of 10 upon 2. So square root of 4 is 2, square root of 10 is root 10. Now root 10 ka value, if you remember, as 3.162, then your work is easy. In case if you do not remember this, then you are supposed to use that log and anti-log ka thing. So if you are into log and anti-log, then this would be half log 10 minus log 2. So in case if you are not following this part, I would suggest you to follow the series of logarithm in my playlist to know how to do this kind of logarithmic problems. The better way would be remembering the value of root 10, or in case if your board allows calculator, if you are belonging from some board which allows calculator, then this would be a piece of cake. Then I'll cancel this 2 1s and this 2 something 1.58 1s. So my frequency would come out to be these many hertz. So that means the particle is oscillating 1.58 times 581 times in a second. So that's the oscillation of that particle whose potential energy is given by this formula. So I hope we are also matching with the answers as well. So we have done with this numerical. It's a very easy numerical, kind of a 2 or a 1 mark problem. Thank you so much for watching. If you are still with me, subscribe the channel in case you have not done so, and keep following the video in a series so that you can understand and gain maximum out of it. Always follow consistency. Every day some amount of data if you accept, then definitely at the end of a month, at the end of the day, you will definitely acquire a lot of amount of knowledge. Thank you so much. Have a nice day. Bye.